Hey guys, today we're going to be talking about the top 10 Docker questions that you may find in a software interview. So, before we get started on the actual interview questions that may come up on a Docker interview, let's kind of give an understanding of what a Docker really is. A Docker is a widely used containerization technology that enables developers to package and deploy applications in a portable, efficient, and scalable manner. Docker is an open source tool that automates the deployment of applications inside containers, making it easier to manage and deploy applications across different environments. In this e-learning script, we will cover 10 Docker interview questions and answers that will help you prepare for any Docker-related job interviews. So, to get started, let's ask the most obvious question in this. What is a Docker? A Docker is an open source containerization platform that allows developers to package, deploy, and run applications inside containers. Docker containers are lightweight, portable, and can run on any system that supports Docker. Docker has been immensely popular in the software development and DevOps communities due to its availability to streamline the application development and deployment process. With Docker, developers can package their applications and dependencies into containers, which can be easily deployed on any system that supports Docker, without having to worry about environment inconsistencies or dependency clashes. Docker also provides a rich ecosystem of tools, libraries, and services that extend its functionality, making it a versatile platform for building, testing, and deploying applications in a fast, efficient, and scalable manner. Another question you may find is, what is a Docker image? A Docker image is a lightweight, standalone executable package that contains everything needed to run a piece of software, including the code, libraries, and dependencies. Docker images can be easily shared and reused across different systems. Another way to put it is a Docker is an image like a recipe for software applications. It's a self-contained package that includes everything needed to run an application, and it's created from a Docker file, which we will cover later on. Containers are the running instances of Docker images, and Docker registries are repositories where images can be stored and shared. So, we've heard this word container, container, container many times, so let's go into that. What is a Docker container? A Docker container is a lightweight, portable, and self-contained environment that runs on top of a host operating system. Docker containers are created from Docker images and can be easily deployed and managed and scaled. You can think of a Docker container as a virtual isolated environment that allows an application to run consistently across different systems. Just like a lunchbox that contains a meal you can take with you wherever you go. Imagine you have a lunchbox that contains all the food items for your lunch, neatly packed and separated from other items. Similarly, a Docker container is a self-contained, isolated environment that contains an application and its dependencies, such as code, runtime, system tools, libraries, and configurations. It's like a lightweight, portable package that you can carry and run on any system that supports Docker. When you open your lunchbox, you can enjoy your meal without worrying about what's inside other lunchboxes. Similarly, a Docker container runs independently from the host system and other containers, providing a sandboxed environment for the application to run without conflicts or dependency clashes. Containers are fast to start, stop, and move, and they can run consistently across different systems, making them ideal for deploying applications in diverse environments, such as development, testing, and production. Just like you can customize your lunchbox with different food items, a Docker container can be customized with specific settings, configurations, and dependency, allowing you to create a reproducible and consistent environment for running applications. Containers are also scalable, as you create multiple instances of the same container to handle different workloads or to distribute the load across a cluster of machines. So, this is a pretty important question that may come up. How is Docker different from virtualization? So first I'll kind of give you the simple explanation and maybe go a little bit more in depth. So Docker uses containerization, whereas virtualization uses virtual machines. Docker containers share the same host operating system, making them more lightweight and efficient compared to virtual machines. So to go more in depth into this, imagine you want to run multiple operating systems on your computer like Windows and Linux, but you only have one physical machine. There are two approaches you could take: virtualization or Docker. So what is the difference between a Docker and virtualization? With virtualization, you would need to install separate operating systems, like Windows or Linux, on your physical machine using a hypervisor, which emulates the hardware for each virtual machine. Each virtual machine runs independently with its own operating system and resources, and they don't interact directly with the host system or other virtual machines. So it's like having multiple computers with one physical computer. Each virtual machine is like a separate computer with its own operating system, applications, and resources running on the same physical hardware. What about a Docker? A Docker, on the other hand, uses containerization instead of virtualization. It allows you to run multiple containers on a single host system without the need for separate operating systems. Containers share the same OS kernel with the host system and other containers, but they are isolated from each other and from the host system. So it's like having separate compartments with a single box, where each compartment contains an application and its dependencies. Docker containers are like lightweight, portable packages that contain everything needed to run an application, including the code, runtime, system tools, libraries, and configurations. Containers are isolated from each other, allowing them to run consistently across different environments, but they share the same host system resources, making them more lightweight and efficient compared to virtual machines. A Docker allows for more efficient, lightweight deployments compared to virtualizations, and it doesn't require separate operating systems for each container. Docker also provides a more lightweight, scalable, and efficient approach to running applications, as containers sharing the same host system allows for faster startup times and easier management compared to virtualizations. Docker and virtualization are different technologies that provide similar benefits of isolation and portability, but they use different approaches to achieve those goals. Docker containers are more lightweight and efficient, while virtual machines provide a more isolation and separation between different operating systems. It depends on the specific use case and requirements of which technology is more usable. So another question that may come up is, what is a Docker Hub? A Docker Hub is a cloud-based registry service that allows developers to store and share Docker images. Docker Hub makes it easy to find and download pre-built images, and it also provides a platform for sharing and collaborating on Docker images. Think of it like this. Docker Hub is like an online store for containers, which are like little packages that contain everything your application needs to run smoothly. It's a place where you can browse through a wide variety of containers like databases, web servers, and other popular software, and download them with just a few clicks. It's like going to your favorite grocery store and picking up all the ingredients you need for a recipe without having to go through the trouble of preparing everything from scratch. And the best part, Docker Hub is not just a place to find containers, but also a community hub where you can connect with other developers, share your own containers, and collaborate on projects. It's like a bustling marketplace where you can discover, download, and contribute to a wealth of containers that can make your application development process faster and more convenient. Whether you're a seasoned developer or just getting started with Docker, Docker Hub is going to be a place to find, share, and collaborate on containers, just like a virtual pantry that's always stocked with delicious ingredients for your application recipes. Another question that may come up is, what is a Docker Compost? A Docker Compost is a tool for defining and running multi-container Docker applications. With Docker Compost, developers can define and manage multiple containers as a single application, making it easier to deploy and manage complex applications. what is a Docker Swarm? Docker Swarm is a container orchestration tool that allows developers to manage and scale Docker clusters. Docker Swarm simplifies the deployment and management of containerized applications across multiple hosts and provides a high level of scalability and availability. So question 8, what is a Docker file? A Docker file is a text file that contains a set of instructions for building Docker images. Docker file instructions can be used to define the base image, add dependencies, configure the environment, and specify the commands to run when the container starts. So you can kind of think of it this way. Imagine you want to bake a cake. You would need a recipe that lists all of the ingredients and provides step-by-step instructions on how to mix them together, bake them, and create the cake. Similarly, a Docker file is a text file that contains instructions on how to build a Docker image. It specifies the base image, sets up the environment, installs dependencies, copies files, and configures the application, all in a series of steps defined in the Docker file. Once you have a Docker file, you can use the Docker build command to create a Docker image from it. The Docker build process reads the instructions in the Docker file and follows them to create a Docker image that encapsulates the application and all its dependencies. This Docker image can be run as a container on any system with Docker installed, making it portable and reproducible to package and distribute applications. Docker files are an essential tool in the Docker ecosystem, allowing you to define and automate the process of building Docker images for your applications in a consistent and repeatable manner. So, we had all this conversation about kind of the different things that go on in a Docker. So what are the benefits of using the Docker? Well, for one, portability. Docker containers can run on any system that supports Dockers. And for two, efficiency. Docker containers are lightweight and use fewer resources compared to virtual machines. So it might be better to use a Docker if you want to use far less resources. Another thing is scalability. Docker makes it easy to scale applications up or down based on the demands, so it may be better to use a Docker in some situations. Another thing is consistency. Docker provides a more consistent environment for developers and eliminates the work on my machine problem. If you've ever collaborated with multiple developers, you may have had issues where it works on one person's machine, but when you start to use it on someone else's, they go, oh, it breaks. So this will help alleviate that problem. Another thing it's good for is reusability. A Docker image can be easily shared and reused across different systems. So for our final question, what are some of the best practices to use with Dockers? Number one, keeping containers small and focused on a single task. It's recommended to follow the principle of one process per container and keep containers focused on a specific task. This allows for better isolation, easier management, and improved scalability. Avoid running multiple applications or services within a single container, as it can make troubleshooting and scaling more complex. Number two, using Docker Compost to manage complex applications. Docker Compost is a tool for defining and running multi-container Docker applications. It allows you to define complex applications with multiple services, networks, and volumes in a single YAML file, making it easier to manage and scale applications. Docker Compost simplifies the process of defining, building, and running multi-container applications, making it a best practice for managing complex Docker deployments. Number three, using Docker Swarm or Kubernetes for container orchestration. Docker Swarm and Kubernetes are popular container orchestration tools that help manage and scale containerized applications across a cluster of Docker hosts. They provide features such as service discovery and load balancing, rolling updates, and automatic scaling. Container orchestration tools are essential for managing containerized applications at scale, ensuring high availability and simplifying deployment and management. Number four, securing Docker containers with appropriate access controls and permissions. Docker containers should be secured with appropriate access controls and permissions to prevent unauthorized access and potential security breaches. This includes securing Docker daemon, securing Docker images, and using appropriate user permissions and restricting unnecessary access to host system resources. Following the principle of the least privilege and regularly updating container images with security patches are important practices to ensure container security. And number 5, regularly updating and patching Docker images to address security vulnerabilities. Docker images, like any other software, can have vulnerabilities that may be discovered over time. It is crucial to regularly update and patch Docker images to address known security vulnerabilities. Keeping Docker images up to date with the latest security patches helps ensure that containers are running with the latest security fixes and reduces the risk of security breaches. By following these practices, developers can effectively use Dockers to create and manage containerized applications in a secure, scalable, and efficient manner. I hope you enjoyed the video about the top 10 questions that may pop up on a Docker interview. And I hope you guys can like, subscribe, and maybe even share this video to someone who you may think would find this video helpful. Thank you.